This video presentation is with regards to obtaining the gradient and the y-intercept of lines, then write the equation. To demonstrate this, we'll use two examples. And first, we'll start with the gradient. Now, we just have to remind each other that the equation of a straight line must have the dependent variable, which is y. The gradient will come here. X is the independent variable plus the y-intercept. So once we get the gradient and the y-intercept, the equation is complete. Okay. So we just need to get the gradient and the y-intercept, and the equation will be completed. The gradient always forms as a coefficient of x multiplying to x, and the y-intercept is the constant, normally called C for constant. Now the gradient now shows you the behavior of y when x increases by 1. Please rewind this, pause this, write this down. Take note of this. The gradient shows you how y behaves. Okay, the value of y, if it increasing or decreasing, but by how much? When x increases by 1. Okay, when interpreting the gradient, we always have to view x as increasing by 1. Always increasing, but specifically for the gradient by 1. So let's look at the starting point. The starting point here is 1. That 1 there is a y value. So this is the y-intercept right away. So if we have the graph, we can get the y-intercept one time. We can get the y-intercept first and foremost. So the y-intercept here is 1. Now let's increase x. Now x is always increasing towards the right. So let's increase x by 1 and see what we've got to do to touch the line. Remember, the line belongs to the y value. The line that you see shows you how y behaves. So y apparently is going down because we have to go down to meet the line. By how much we have to go down will give us the gradient because we increased x by 1. So we are going down 1, 2, 3, 4, 5. Okay, because each box, each centimeter cube is 1 unit. You see, the y interval is 1. So since we are going down, the gradient is a negative number. And by how much again? Let's increase x by 1, 1. Let's see what we've got to do. We've got to go down to meet the line, to meet y. By how much? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the gradient is negative 5. So here is the equation. Y is equal to minus x plus 1. Here, the line is going up. That means y is going up as x is increasing from left to right. So the gradient is a positive number. You don't have to write the positive sign. If there isn't any sign, then we know it's positive already. The starting point is negative 3. That's when x is 0. So y is negative 3. X subtract 3. That will be y-intercept of this line, negative 3. Now we're going to start at here on the y-axis, and we're going to increase x by 1. And we're going to see what we've got to do to find the line, to find y. We have got to go up. So the gradient is a positive number, as we have proven before. But by how much? From negative 3 to negative 2, 1. So the gradient is actually 1. Each time x increases by 1, y increases also by 1 also. So the gradient is 1. If the gradient is 1, you don't have to write the 1. If you don't see any coefficient in front of x, there's an invisible 1 in front of the x. So the equation can remain that way. Y is equal to x minus 3. y is equal to 1x minus 3, or you can just leave it as y is equal to x minus 3. The gradient is 1, and the y-intercept is negative 3. So that's what you do to obtain the equation of a line if you've got a graph. It's easier to get the y-intercept first. Just look to see where the line touches the y-axis and start at a point. You can start at the y-axis and increase x by 1 and see what you've got to do to find the line, which is y. If you've got to go down, then the gradient is negative and count by how much. If you've got to go up, the gradient is positive and count by how much. Here we got negative 5 because we are going down to meet the line. We got 1 because we are going up to meet the line by 1.